here.
All right.
Okay, welcome everybody. We are looking at design review for machine learning for upcoming version of Wolfram language. So where do we start?
Well, I would just keep the first one because it's probably the one that will take more time. So I don't know, Roger, what do you think? Is either the first one it will take a lot of time, or we put it as a
Which image? I want to see image entity detector. I've been excited about this for a long time.
Exactly. So yeah, I'm sure we are going to have to discuss names and stuff. So I guess either we skim through the rest, or we just start here. Maybe we just have another meeting.
What just happened? Oh my gosh! I think this just the prototype build just crashed when I opened DocuTools. Great.
Actually, I had that happen today too, or yesterday. Yeah.
Am I going to succeed here, or is it going to fail completely?
Good point. But I'm on Windows.
Just crashed again.
Okay, so it's well.
Right, I can open the documentation in the earlier version and copy paste things.
Yeah.
What just happened? Wait a minute. Oh, for goodness sake. Okay, hold on.
There's DocuTools.
Yeah, I know, but that was all right. So I need to pull up the other. That's for the older version. And now for this version, I'll bring up your page here. And so these are running in two different versions.
Okay.
Okay, image entity detect.
I think I pushed some fixes, some typos like an hour ago. So if you pull CVS, you should get the most recent version.
Does it matter?
Well, not on the big scheme of things, probably. But
okay,
yeah,
I'm not going to save this back. So
okay.
Okay, so let me understand what this is. Really, entity? Is that the right term?
This is a thing to train. The mission of this thing is to train, and you get, but it's sort of lightweight training, requires relatively little, not that many examples, because it relies on an already trained backbone network.
Okay, so I understand it's transfer learning, but so I don't understand the function. We've been through this before. I mean, this should have kind of, the basic structure should be examples, comma, thing to look at. So in other words, while you are generating a classifier with the one argument form, there should be a two argument form that just does the whole job type thing.
Okay.
Yeah, the big okay, so you want to do like classify.
That's what I think, yes. I mean, if you're going to have a name like this, that's what we have to do.
I'm not super sure about that. I'm planning to make it faster, but this thing here, it's an inherently slow operation. I'm just wary of advertising that use case if the training could take between like 30 minutes and 3
fine. Well, this
hours.
is exactly what we had yesterday with, this is what we have with the noun form versus the verb form.
Right.
And first point is, I really don't think we should call it entities. Entities mean something very definite in our system. I think it's more like objects.
Yeah, I mean, what we did, the naming scheme, I think is great in the sense it's uniform and it is entities. But if you feel strongly about it,
no, we can't do that. We've got all this entity star functionality.
Right. What do you think that the detector function? Do you think it's still an entity detector function? Because it's unified. It goes out to, they both text entity detect and image entity detect produce.
Okay, we got to get good names for these, but
So originally we started by thinking of generalizing just classify. And actually, Jerome convinced me that the trainers for text and images are not. I mean, first, we only have like two cases that really make sense right now, text and images. And the trainers, they have very different timings, and the kind of the entry point are very different. So I like that we have a single detector function at the end. I'm not so sure anymore that like what I originally proposed months ago was kind of a sub-cases classify or object classify, component classify, I think we were like toying with.
Yes.
I'm not so sure we can actually provide. I mean, that name would be kind of a very
Why
empty
not?
at the
I mean,
beginning.
you're saying because it only works for images and text.
Also, I don't know, I feel a bit uncomfortable having a function that if you put images will take 3 hours, and if you put text will take like less than a minute, probably.
Fine, but then let's not right now have the master function that works supposedly universally. I mean, by the way, Ethan on our live stream is commenting about new entity objects. Yeah, but these are new entities, right? That's the whole point here.
I mean, you could argue that you could put entity object there, like stuff would head entity instead of a string.
No, it doesn't matter. It doesn't matter. I mean, this is just a payload. I mean, this is just like
exactly.
So, okay, let me understand what this is doing.
Mm-hmm.
I don't need to give the bounding box. Is that a true statement?
No, it's false. We could make it work that if you don't give it, we automatically infer that the bounding box is a whole image. I think I had the design for that. But in general, like this is like a toy example. In general, you will have sub objects, not the whole. This is not classified. Let's say this
right,
is
but on the image,
yeah.
Is there a way of encoding a region of interest as part of the image object?
Not right now, and definitely not for text. So you're looking for a simpler training syntax.
Well, how do you get? Don't we have a way of representing an image with a region of interest for other functions?
No, I mean, our goal is to add annotations to images for that very reason. Because there's not only here, but you can think of sort of medical workflows. That's kind of what you do. You mark up, you mark up a subpart.
And we should also imagine annotations for text.
Yeah,
we had a couple of meetings about that. The problem is that like string, like head string doesn't.
I know, but that's
object,
why. That's why, for example, text element, which is what we use in text structure, is the kind of thing to go for, I think. Right, text element allows you to structure up, symbolically structure what would otherwise just be a string.
I look into that, and it seems very tailored to grammatical units more than
let's look
semantic
at that. I think we should take it apart, because I think we have a similar thing, code element, that we're intending for abstract syntax trees for code. I think it's going to be a family of things. Okay, but let me understand what's going on here. So this is saying that in this image, there's a single object, and at that location, it's this. So in the future, we could expect that the image would itself have been marked up with annotations that could basically say the same as that right-hand side.
Ideally, yes.
Okay.
But at this point, it could be even a notation for both. Like you could have bounding box and class. Why should you provide the class separately?
No, I agree. I mean, but I'm saying that even this picture could have one bounding box for the main apple, one bounding box for the leaf, et cetera, et cetera, et cetera.
Yeah. In principle, yes.
In its okay.
So in that case, you could run the trainer on a list of images with such annotation scheme, and that would be it.
Okay. Question. In image contents.
Yep.
What does that return relative to the if I just run here, if I run image contents on this, does it return something in the same format as that thing is eating? Talking of apples?
No, it's returning an association. It's returning something similar to the output.
So let's take a look here. So what I'm going to say is clearly this this right-hand side should be able to be the thing that you get back from image contents.
Yes, definitely. And I'm supporting, like, I haven't exposed to the top level everything, but the internal design is supporting actually its own output, so you can refeed that.
Okay.
Yeah.
So this concept of a concept is probably not the right thing here. I mean, that's the
well, that's a concept entity. That's always a concept entity.
I know that, but I mean, so I'm thinking that there should be an element here that's called identification or some other thing that is in general this thing here, right, needs a name were it to be in an association.
Is typically class. We have been using class. I mean, this is exactly the same class as classify. So
okay, fine. And does it have an association form that uses class also?
Yeah, I mean, if you look at this is an old page, so the output here, you see the try detector on the new image in the ref page. It says class Apple probability region. We actually renamed region to bounding box because we were attempting to have a more consistent syntax using region everywhere, but it was actually very confusing because we use bounding box for images all the time.
It's a bounding box. It's not a region. A region is something that could be the shape of that could be shape of a potato. That could be a region in our computational geometry system.
Yeah. I mean, it was a aborted attempt to have the same key for text and images, but in the end, we just went for bounding box for images. And yeah, class is going to be Apple. I debated this with Rom a bit, and his what is in the updated page, his proposal was to have class and image as return properties. So what you see here as image and concept in image contents, so that you immediately see what's there and what it is. And for text, you would have string and image. But I mean, the default return type.
String and class.
Yeah, sorry, my bad. String and class. Yep.
So image means the carved out piece of the image in its bounding box.
Yeah, we use it also for stuff like find faces. You can ask for bounding box or image.
Okay.
So we have some consistency there.
Let's go back here.
Yep.
Okay. So what you're doing is you are spending a long time building building this object, whatever you're calling it here, the entity detector function. I don't like the name, but and you say the workflow is such that it is implausible ever to give, here are the things I'm looking for, this is what I'm looking in, and to have that work in real time, so to speak, that you're always going to end up doing the one argument form.
I think for images, at least, it's not realistic. I have a design in mind, I mean, an implementation in mind, but it's not mature yet. The main problem here is that the text is very easy to to cut into pieces. You have like the boundaries of words is a very clear thing. Yeah. So what Jerome is doing is like he handled the text part. That's pure fine tuning of the classification. While for images, you need to relearn to find these new objects, and that is what takes a lot of time.
Why isn't all this YOLO technology? Why isn't that relevant to this?
It is. I mean, the point is that you don't have any guarantee that what the network was trained before is relevant for your new classes. So if I want to find an object, the network, if you use the proposals from the old detector, if you miss the new object in this proposals list, then you will never find anything.
Okay, but to me, this sounds like a technical issue, which is going to get solved. Maybe not this year.
No, yeah, exactly. I'm already experimenting with a kind of class agnostic object proposals. It's just not mature yet.
Ethan on our live stream suggests that detect should be the super function. That's an interesting suggestion.
Well, we were planning, so here I added this image entity detect name because I was trying, and you have some examples below if you scroll down in the page. I was trying to see if this could hold other detectors, like find faces or find text. They are sub examples of this. And we could have, similar to what we have, like built-in classifiers. This could be very easily extensible. We could have detectors as Wolfram function repository submissions. I think Roger proposed this is a nice idea about extensibility. And we can pre-train a bundle of those. So this could be an umbrella thing.
Where are the classifiers? Where are our named classifiers? They're not in the neural net repository, are they?
No, they are Parklets. They are Parklets. They came.
Right. So I mean, one thing we should be doing is making a repository of those, right? The named classifiers. That's actually something we should have already done. I mean, like there are things in the neural net repository. Like there's a demo that I often use of that neat network that you give it a photograph, it tells you where in the world it was taken.
Yeah.
Right?
Yeah.
That should be a built-in classifier.
We look into that a bit, like how to migrate, because that thing came way before the data repositories in general. And I think it just stayed there for a while because at first we didn't have versioning. It was a bunch of technical limitations. But I was discussing this actually before leaving with Timothée. And probably for the next version, when we have a bit of time, we were looking at how to migrate all those
okay, but let me be specific.
Things.
I mean, what we have right now is a neural net repository. One of the things we're planning is more lightweight repository making. And so what is coming out of this discussion is we should have a classifier repository, we should have an anomaly detector repository, we should have a detector repository, etc.
Okay, that will be my next question. Like, do we want to proliferate repositories or start like subsection inside one repository? Okay, and then
we should proliferate repositories because that's what, it's intended to be a general framework. The repository, the resource system is a general framework, and every repository we've done.
So now we need a repository.
We do, yes, we do. And there's already a plan for that.
Okay.
And
okay, no, this answers my concern because I was a bit wary of the cost of setting up another one of those.
The idea is that they're going to be lightweight. I mean, like for example, one, Roger, that you should have heard about is the color palettes repository, which I think we really need. I mean, I want to get rid of these random sort of things where we've got a random set of palettes here. These should be repositories.
The color data thing.
Yeah. Yes, should be a repository. And because there's a lot of things we don't have there, and each one should have its page, it should have a name, blah blah blah. It should be searchable for. You should be able to have guide pages for it, the whole 9 yards, which is something that comes with the repositories but doesn't come with something that's just a little palette somewhere. Okay,
can we avoid using new heads? Like, and this is, I ask this also to bring back the discussion because it's relevant to this detection framework. So can they classify the built-in classifiers in the repository be accessed through the classify head?
I don't see any reason they shouldn't be. Just like NetModel accesses things in the neural net repository.
Exactly, but NetModel is not, it evaluates to a neural network. It's kind of it was a thing added on the side, like a kind of nice wrapper. While classify we already have as a head. But I mean, I agree.
No, but I mean, my point is, I don't think that there's any, if I say classify, like,
it comes out as a classifier function, right?
Yeah, exactly.
Which is just fine. I mean, this is just, it will retrieve its classifier function from the, from the repository. That's just fine. Beautiful. This is the right way to do it. Now, the question is whether we can do that with detect. Okay. And so what would happen if we had, okay, so this would be an image detect. And then it would be And the thing is, okay, so you're detecting things in the image. Now, how does that go with, I mean, the other detect functions that we have anomaly detect, right?
And yeah, color detect.
What is
yeah, and then we
color
have that's to find something close to that color in the image. So you see,
Okay, so what does it
image
return?
red.
What kind of a thing does it return?
A mask in that case.
Mask.
Okay.
That's similar to the like crossing detect, edge detect.
Okay, which return masks.
Exactly. Which was our kind of standard things, like are the list of points or a mask were our two typical return types for images when you were looking for things.
Right. Ethan is commenting, these classifiers need to be benchmarked, and they need test data sets and performance data.
Yeah,
interesting
right.
suggestion.
From you mean in the repository submission?
In the neural net repository, for example. It's a good suggestion. I mean, I'm sure we could automatically add a bunch of that stuff. Given a test training set, we could absolutely add performance information, although I don't know quite how we would do it, because it's like performance on what? I mean, on my desktop computer, on my, on a, is there a good standardized
No,
way?
you don't typically, for performance, you don't typically mean speed.
They mean scope.
Accuracy.
What a range of problems that can be solved. That's usually what we call scope.
I see.
But they call everything performance.
Precision of recall and things like that.
Yes.
Yeah, exactly. Accuracy, stuff like that. But you can also report the flops. But in that case, they typically say
it's
on a heavy system or like 4 TPUs, this is the flops. We do report performance when we have them in the net repository. I'm actually pushing for a bit more tables of them.
Look, I think that we should call this object detect. I think detect on its own is too, there's too many of these things. And I think what we would then have is image object detect, which would be this function here, which is essentially what you're talking about, except we'd be calling it object detect.
Mm-hmm. So we create these two with the idea that when we are ready, we create a general object detect that can take everything.
That would be what I would think, yes. And I mean, I would say that
is object detect going to fit correctly with text, do you think?
I was thinking about that. Because
that was the dilemma we had when we were trying, thinking of names.
Yeah. Well, what are we calling? I mean, in text cases, how do we describe text cases? Because text cases can detect all kinds of weird things.
Yeah, that's the pre-trained version of this.
I know, like being of type, whatever it is.
Right.
Let me see. It's not even text entities. It's not entities, because you can do things like, it doesn't matter whether it's an entity. We can have things like nouns and so on.
Yeah.
What do you call all that then?
Content types is what we're calling it. Look, whatever happened to our idea of having kind of image patterns as the thing that would represent, in classify. Okay, I'm confused. Back ages ago, like 3 years ago or something, we had a design for these kinds of things that involved some kind of image pattern construct.
We thought about that. It's it isn't giving, like, if you wanted to evaluate, isn't giving it, like, you will still have to find features in a meaningful way, which is I mean the big problem is you need the full image to do the training. So if I extract only the feature, I can only do that with the other approach that I would like to do in the future, where you have something that is able to detect object proposal everywhere, like semantically segment an image, and then you use your pattern object to match and find if something is close or not. But right now, you need to train the localization part. And for that, it's very difficult to say before what are the features that you need. You want to start from the full image.
I see.
So we throw away too much information with that. I would like that as well. But yeah, if we could segment properly in a meaningful way, then that image pattern object would basically, would be a good vector representation of the image.
Why am I not seeing feature? Oh, it's feature extract, not feature detect. Okay, so image. Look, I mean, one possibility, I don't know, I don't really like that very much. Text content detect. Image content detect. The problem with detect is that these things are returning a mask indicating where the detection occurred.
Mm-hmm. Yes.
All of them. They're not returning
Yeah.
they're not returning the cases analog of that. They're returning the position version, not the cases version.
Well, we do have, for all the anomaly detection, feature extraction, missing imputation, we had this threefold thing where you have, like, for example, you have feature extract, feature extraction, and feature extraction function. And one of the two returns the function and the other one operates on the data directly.
No, I know, but I'm making a different point here. I'm saying there are two things when you try and find an apple in an image. There are two things. You want the specific apple you found, and you want, as opposed to, because you're feeding in a class of things, a class of apples, but you want the specific apple, and you want its bounding box. Right? Just like facial features, whatever.
No, sorry, I'm not sure I follow.
I mean, I think you want where and what is what you're saying, right?
Yes, that's correct.
Okay, but these ones here, the what is given, like edge, it is an edge. Max is a max.
I know. That's my point.
Right.
My point. There isn't a what.
Right. The what is in the function
exactly.
name. But these more general whats, where there's a whole world in the what, we want the specific what. Or more specific what.
No, I know. You're returning the cases of. I mean, let me see. It's just like a classify. You don't do that because you're given the whole thing and you're just saying, how is it classified?
Exactly.
Okay. So what we need here. Let me think. So, I mean, I think I understand the functionality. And in the text example, I assume what I'm doing is I'm saying what are you giving us as training data there? You say this word.
We give a text, which is a string, which is a position, which is similar to the image. And then you say this position is furniture. This position is, okay, this one is training only on furniture. But the one below is fruit or sport, for example. So it's like a position and class, similar to image.
Ethan is complaining that there's no multimodal, multi-net encoder examples, no captioning summarization. What's VQA? I don't know what VQA is. I think that's what we're dealing with here is this question of what happens. How do you get something where there is both this is an elephant and here's an elephant, here's a rhinoceros, and here's, okay, so we're both feeding in that's kind of weird. Yeah, okay, so you're going to fix that. You're going to actually give the string here, right? You're not just going to give the position.
Yeah. We change. We change. If you pull CVS, you will already see that we have string and position, and in the image case we have image and bounding box.
Right. Not sure about the net functionality. I mean, the things like captioning and so on. Don't we have networks that do that? But we just don't have. We have not made a standardized version.
I don't think we have converted any captioning. We definitely haven't trained any captioning network.
Right. I mean,
but it's easy to take this output to highlight it. I mean, actually, this should make sure that this fits together with highlight image, right?
Yes, I have an example. If you go to the image entity detector,
and we would like something similar to highlight image for highlight text.
We would. I thought we had a highlight text. Did we finish that design or not?
I don't know who works on text. Is one of these where we don't. It's a little bit distributed, right? It's not.
I thought it was Jerome dealing with those kinds of things.
Well, Jerome did a lot of work for the text cases. If you go to text cases, you will see the highlight snippet. But
not sort of the core infrastructure stuff.
No. I mean, he did that on its own because only on his own because he needed the functionality. But there was a discussion that at that time I wasn't part of, so I don't know where it went about doing that generically, like a general framework, like highlighted for text.
Right, it's something we should talk about further. Okay, coming back to this. So the issue is the name of the function that is going to take it's going to take specifications of sub pieces, and it is going to, so the return value will be like facial features. It'll be this whole association, correct?
Well, we were thinking about the whole association. We wanted to add more properties, so we are not returning all of them. We will have ideally a default set of properties that we return, and then you can specify if you want something different. You can specify that. You can say just give me the image, or give me also the probability. Give me the highlighted snippet.
Right, but I'm not buying the fact that you're never going to be able to do a one-shot version of this. And by the way, you could even do some behind-the-scenes caching to help with that and so on.
Yeah, I mean, we can have a design. We can support it. It's not killing anybody. But this is also something that was bothering me a bit in all those classification or like not detect functions in machine learning that. I almost never want the direct result because I want to tweak this stuff and experiment. And I'm always wary of throwing away even 10 minutes if I cannot reuse it.
Right. Okay, fine. Okay.
But we can definitely support it. It's not a blocker.
All right. So look, the natural name. I wonder about content detect.
Content is fine for text. Let's say it's
fine
for
images?
Audio. Is
image
fine
content
for images.
detect.
Yeah, we have image content.
Oh, we have image contents, don't we?
It's the same as text content. One is the one that tries to find everything and gives you a data set as a result. And the cases function is like cases. You put what you want.
Well,
and
I would argue then that we should just standardize on image content detect, because content is.
I agree.
This is
okay. Okay, this was good. This is kind of what we were looking for to standardize on. But
right,
the content it's better.
Yeah. Okay. All right. Okay.
Because then we can have a content detector function.
Exactly. So then this becomes. Yeah, content detector function. And eventually, it would just be pure content detect, not text content or image content detect.
Yeah.
Yeah.
Should we do that immediately and just say it only supports text and images right now?
We can. We started the design that way. Jerome actually lobbied me very hard to separate them. And at a certain point, he was able to convince me. I don't remember why he was able to convince me, but he was definitely able to convince me. I think it was...
They have almost the same options.
Yeah, we tried very hard not to depart. I mean, we thought that them together. So and I tried to keep them together. So...
By the way, I mean, the image content detect of face is going to give a content detector function basically of face.
Exactly.
Right?
Yeah.
So, I mean, it's kind of like just the pass-through thing. That doesn't matter. You could say image content detector of that too.
Sorry, I didn't get the
no, I mean,
point.
Look, you say image content detect of face.
Yeah.
Returns an image content detector that is basically a face image content detector.
Yeah, it will return like a content detector function of type face, like pre.
Yeah, I know. But as well, you could have typed in content detector function of quotes face, and that would have been equivalent.
Yeah. I was actually thinking of doing that. If you want to have that as an entry point, I'm not sure if you want this image and text as entry point. We could have that you can access the reason why I didn't implement this is that Classify is doing differently. But even for Classify, I would even prefer Classify function to take the...
Okay, well, let's look at that. Yeah. I mean, and as we put it into a repository, we can, clean that up. Okay, so what I'm seeing here makes me think you should do one more pass of, can we just make content detect the single function from the beginning? If we can't, we'll have to have these two as experimental functions, and then subsequently
I think, Julia, could we just first of all transfer these names to be sort of the content case, and then we write a third page, which is the overall thing.
Yeah, and then to see what happens.
Yeah. Sure.
Okay. All right. Let's move on. I mean, unless there's more to talk about with these functions, doesn't look like there is.
No, I mean, this wasn't the main, the name thing and the kind of how to fit them in was the main.
Okay, fine. Let's move on.
The main point.
Okay, dimension reduction. So that means feature space plot starts to look different.
I mean, we are not using TSNE. I think for feature space plot we use something faster, but this is a very popular method, and we want to have
so it's just an alternative method. So it's method arrow umap or something is an alternative method which will work in feature space plot.
Exactly.
Okay.
We are working now to make it as fast as possible. It should be a fast method. So we are writing some custom code to make it faster in the implementation.
Okay. Predictor function, classifier function, decision tree as a tree expression. That's cool. I want to see that.
Okay, so here we have a design problem, because this is something that I really want to have, but we need to decide. So right now, I think it makes sense only as a toy thing. I don't even know if we want to expose it. Because, and the reason why is we have three methods like decision tree, random forest, and the gradient boosted that train trees. The point is that we have very sophisticated data processing pipeline, like standardization, missing imputation, conversion to numerical vectors, and the tree is trained on the output of that. So as much as I like to probe this direction, because I really want to have stuff in tree form, it will not be immediately useful, because you will not see the input of a tree. The nodes you split on is not the original data. So,
okay, how different is it? I mean, standardization and things like that you can kind of work through.
Okay, but if it's a string, for example, it might become something, a vector of length 4. What those things represent? It's just an embedding space.
So you mean after the feature detection? You're saying the tree operates after feature detection.
Encoders. I mean,
I think it's the same thing. Like it's a feature extractor. Let's say.
Right. Okay.
It operates after the encoder.
Yeah.
Is what you're saying.
So we were exploring with Jesse, like one idea was if you want to work to go down this interpretable machine learning way, we could have for some setting that we always train a tree to represent whatever, like black box classifier. We train
confused.
a tree.
Okay, so you've got a mapping that going through the encoder. You have an elephant, and the elephant turns into a vector of numbers.
Yes.
Whatever it is,
yeah.
Right. And so now, and then, okay, so just, okay, given a particular data set, you know, these elephants, these rhinoceroses turned into these sets of numbers. Then you know there is a break between two sets of numbers that is the decision tree.
Yes.
Right? So a way you could visualize that is, there is a break in this in sort of feature space, so to speak, for the decision tree. But just like a feature space plot, you're basically visualizing, like how are you going to represent? You've got rhinoceroses and elephants on one side, and you've got cats and ferrets on the other side, or something, right?
Right.
Mm-hmm.
And they are split in the decision tree. Okay. How would you ever imagine you're going to show elephants and rhinoceroses other than the way we do it in feature space plot, which is to take the original data and show the elephants and rhinoceroses? So in other words, what I'm claiming is your decision tree should have, there is some slice, some point at which it makes the decision that's somewhere in between elephants and rhinoceroses and cats and ferrets. Okay.
Okay, I understand what you say. I'll stop you here because the point is the feature vector, classify is more generic than that. The feature vector could be one text element, a sentence, a number, a color, and a date.
Okay.
And everything is dimension reduced together. So
I know. I'm just saying there is a set. Okay, so here's my point.
Mm-hmm.
Let's say there's 100 initial. The training data contains some amount of data, right? And in principle, you could represent decision space. So what is a single break in the decision tree? It's basically in a feature space. It is a line in feature space, right? It's a slice. And feature space has all of these different animals laid out in a feature space, right? And a particular branch in the decision tree is these animals go to the left, these animals go to the right.
I think the real point is that I'm not sure, I should check, but I'm 99% sure that not all the feature extractors are invertible. And this is what
I'm not saying it's invertible. It doesn't have to be invertible. All that has to be true is that okay, here's what I'm suggesting. So if I go to boy, I have been doing so much live streaming today that I have not eaten enough. I'm going to fail through lack of food soon, especially since we have another live stream coming right up. Okay, so let's take one of these cats and dogs. Okay, so what I'm saying is you've got certain training data. Okay, and you could lay it out in a feature space if you wanted to. So I'm saying the decision tree, you can always draw that with respect to your original data as some kind of partitioning of this original data. Every tree branch is some partitioning of data, correct?
Is partitioning the feature space. Yes.
Yes.
I understand, but you can represent that as a partitioning of the original data. You've drawn a feature space plot, and so which is a horribly dimension reduced version of feature space. But what I'm saying is, there is some separator, might not be a straight line. There's no guarantee of that. There's some separator. These guys goes on one side and these guys go on the other side, right?
No, I see your point. I'm not sure that mathematically it will be always possible. I want to look into that more. But
fail to be? How could it fail to be? I don't understand that. You can always make, with respect to the original data.
No, it always is. It's always a partition.
Yeah, at every cut must be a partition of this original data goes this side, this original data goes that side. And so what I'm
but you need to
suggesting,
describe that analytically.
no, you don't. That's not what I'm saying. You don't need it. That's my whole point. My whole point is, imagine the tree. Okay, you're drawing a decision tree. What I'm saying is, all you do in the nodes of the decision tree, all you do is you give the actual, the 300 examples of training data that go to the left, the 400 examples that go to the right. Okay, so in other words,
okay, no, sorry. Okay, this was my confusion. I was so okay. To do this, you need to basically save the whole training data together with the classifier. I was actually under the assumption that you only have the classifier function, not the original training set. But yes, if you have the original training set, you can do that.
Right. So then the decision tree, what you would do as a visualization of the decision tree is you would say, okay, I'm going to make samples of these different things sliding on one side or the other.
In that case, you can. We
so
can.
That is a way to make a decision tree.
But that's more like something. I think that some of these have kind of these different homes depending on and properties, depending if the property is in classifier measurement or in information. Because if it is in classifier measurement, you have some data, and then we could do that in that case. Yes.
Right. But
what did you imagine decision tree would put out? I mean, I was thinking of it as an actual decision tree, meaning that the sort of Boolean condition at the node.
Right, but the point is that the Boolean condition is on the output of the encoder, and that's why it's absolutely meaningless. I mean, this thing is
it requires that encoder to run, but it would be on the encoded data. Yes.
Right, but so there are two decision trees that are relevant. Either on the encoded data, because you have mapped by the feature space, by the encoder, you've mapped it into Euclidean space effectively.
Yeah.
And so at that point, it is an algebraic condition or linear condition often. It's a condition in Euclidean space.
Or right? For a nominal tree, for a nominal split, is it 1, 2, and 3 goes in this direction, 4 and 5 go in the other direction?
Fine. Well, so this is more like that. This is saying of the 1,000 training examples, 400 go in this direction, 600 go in that direction. Think about it like a nominal splitter, categorical splitter, right? And that's an alternative. The other case that you talked about, once you've Euclideanized it, so to speak, once you've sort of spacified it, then it's something. What am I trying to say? Then you can be more algebraic about those conditions. But either of those is perfectly interesting. Either case is interesting.
But what would you imagine that we produce in that first case with the examples? Like
which first case? Sorry.
When you haven't encoded it, and sort of, did you expect the decision tree to have a bunch of examples sitting at the various nodes?
Yes, that's what I would expect.
Oh, okay.
I would expect that yes, that's what I would expect.
Okay.
And in principle, it could have the whole bag of all training data that went to the left and all training data that went to the right. I mean, essentially pointers to all those pieces of training data.
Mm-hmm.
And you could sample it with examples of that training data. I think that will be an interesting decision tree. I think it'll be a useful decision tree. I think I could imagine something where, you can drill down, well, which exact, what were the features? So to me, this is somewhat.
Oh, I can see where I can learn something from that, actually.
Right. I mean, in a sense, learned distribution is, learned distribution is the thing that is sort of taking these images, for example, and turning them into a space-like thing. Ethan is complaining that things like feature space plot don't deal with hundreds of thousands of examples, and they should. Why don't they?
What?
There are two bottlenecks here. Like one is, and I expect is that not so big one, visualization, and probably the biggest one is feature extraction, that it might take a lot of time to process.
Do we parallelize the feature extraction?
Well, if it is a neural network, which typically is, it is already parallelized because we.
No, but it's not. It's only multi-threaded. It's not. For example, we don't have. What happens if you have 100 cores? Can you actually run? If it's feature detecting zillions of things, you should be able to run that in parallel.
But it is. I mean, so the neural network is. If you have, like, say, you have a 64-core machine.
No, I'm not talking about that. I'm talking about if we have our parallel framework. Like I have 157 cores, I think.
Yeah, but then so none of that is probably none of that's used.
No, this is not. It doesn't support parallelize, but I think that most of the feature extractors are neural networks. So calling parallelize wouldn't give any improvement.
Yes, it would. If you have multiple machines, it would.
Oh, multiple machines.
Right. Right.
Is parallelize working on? Okay, I didn't even know that it was working on multiple machines. Okay.
Of course it does. That's its main point. Yeah, it's its main point. It's not just single. It's whatever kernels you have available.
Right.
I mean, I think that. Look, by the way, the business about the visualization of feature space plot, that needs to be looked at, because I've noticed that issue as well. That we just need to make sure that it actually works with very large numbers of points and so on. Okay.
I think so that can probably be parallelized. That's the actual feature extraction. But the other key point when you visualize big things is that you don't visualize everything. You subsample.
No, I know. We need drill down. But the first thing is there's just straight optimization of the way feature space plot works. We've done a couple of iterations of it. If somebody who's taking notes here, we need to point that out to Brett and make sure that we do one more round of that.
Sure.
Fair?
I've got it.
Okay. Let's see.
It's probably going to come back to the ML team.
Right. Let's see. Marco is suggesting for image content detect, you can have an operator form that finds the bounding box. It's more complicated because you can both find the thing that was detected as well as the we need to go to our next meeting, which is also a live stream.
Well, I'm going to ask for another hour of this.
Yes, please. Yes, we need to do that. Ethan is commenting that we should have a documentation section of real-world examples with at least 100,000 samples, and it's a perfectly reasonable suggestion.
Yeah. You mean in feature space plot now? I mean,
no, in general, in machine learning.
Oh, yeah. That's I typically keep it low because there was complaint about the size of a ref page. Now that we ship it separately.
No, but this is where we use data repository and other things to pull in big.
Right. And I think the main point is just to show the workflows, and perhaps they should be in workflow documentation to show the workflows for large scale computation, so to speak. Because there are different issues that come up, like this thing about feature, like the feature detection being parallelizable, which I hadn't even thought of, but that's a reason. I think, I did a bunch of feature space stuff for the physics project about a year ago, and I did do a bunch of parallelization there. I did all kinds of weird hacks. Like, for example, one weird hack I was doing was on parallel machines, I was rasterizing a bunch of things to use as the images to display and so on. I had to do a bunch of weird hacks, particularly involving parallelization, to get that stuff through.
I mean, we can definitely look into improving that. I think it's probably due time to have an update. And about this thing, like one stuff that is not documented here but is supported is you can use the image content detector with files. Like it trains out of core as well if you want.
Oh, that's interesting.
We can probably
that should be documented.
Yeah, I mean, I prepared that. Is again, this started with classify was another point of difference. I think I didn't do that at the beginning because it was between. It's not super clear. If you have a single head, should you expect an image head, a file with an image, or a file with something else? But I want to look in. If you want to bring back the unified design, I can look into that again.
I think that'll be good,
because that is the only way to train with a very, very big data
set. Right. We should wrap for this meeting, and for those following the live stream, we have one coming up about graphs, geometry, and graphics. The 3G.
Yes, actually,
sounds very out of date. It should be 5G at least, or 6G or something by now.
Right.
Okay, I will see you guys in a moment. We'll be on